Today we'll turn to the topic of solving quadratics. Typically, quadratic equation, anytime you see an x squared in that problem, it's going to be a quadratic. General form is ax squared plus bx plus c. And there's three basic ways we're going to look at solving it today. The first is going to be by factoring, second, completing the square, and lastly, the quadratic formula, which is what you've probably done the most of. Other than factoring in the past. So let's start tackling that kind of stuff. So I see an x squared in my problem. I know it's a quadratic. My first plan of attack is to set the whole equation equal to 0. And if I look at it and see, hey, I can factor that, then I'm going to factor it. I go to the quadratic formula absolutely last. So I put my x's here. We've already covered factoring. We need a 6 and a 5. Negative 6, positive 5, still equal to 0. Zero product principle says if you have any two numbers and they're equal to 0, then either a equals 0 or b equals 0. And that goes for as many terms as you can multiply to equal 0. You could have C, D, E, and F, whatever. But that assumes that you can factor all that stuff. So anyways, I'll do this one time and one time only. X plus 5 equals 0, x minus 6 equals 0, and x equals 6, and x equals negative 5. Problem done. In our next example, again, I see a squared term. There's a couple ways to actually go about this. I'm going to do both ways actually because it's going to lead into our next conversation. I can say 49x squared minus 36 equals 0. So then I have a difference of squares, 7x minus 6, 7x plus 6 equals 0. So x equals 6/7 and negative 6/7. Again, by setting each of those equal to 0 and solving. Now, the other way I can do this is by going through the following process. Say 49 x squared equals 36. Notice I just brought the 26 to the other side. Say x squared equals 36 over 49. And then what I can do in this case, I know we really haven't gotten into it, but I can say what number multiplied by itself is equal to 36 over 49. I can do that in my head and say, well, that's either 6/7 or negative 6/7, because if I square those, then that's going to be my answer. And basically what I did was I square rooted both sides. Do this in green. And I know that if it's a squared term, I have the positive and negative answer. So I say that's just plus or minus 6/7. And like I said, that's going to lead into our next topic. So if I look at a problem like this, I have a couple of choices. I can FOIL this out, set aside equal to 0, probably factor and solve. Maybe, maybe not. In this case, I don't think that's going to work. Or I can use a concept that I just used. I have a term, some term, let's call it a happy face, squared is equal to a constant. So if I were to square root both sides of that, then that would be the happy face equals plus or minus the square root of that constant term. And that's what I'm going to do in this case. I'm going to square root both sides. So that x plus 4, because it's like a quantity squared, what multiplied by itself, is equal to that constant. Well, that term is equal to plus or minus the square root of 3. Then I just have 4 equals, or I'm sorry, x equals negative 4 plus or minus the square root of 3. Now, the only way you would have gotten that, other than by doing the process that I just did, was by taking and FOILing this out, setting it equal to 0, realizing you couldn't factor it, and then using the quadratic formula at this point. Now, little giveaway on the plot is that this term right here is a perfect square, because it's a term squared. All right. And we're going to do is start talking about dealing with perfect squares. So you say in this case, it's basically the same problem as last time. This is a perfect square, but it's not factored. So if I were to factor that, again, I could bring the 13 over and try to factor both sides and see what happens there. Or I notice, hey, that's a perfect square of x plus 5 squared equals 13. Now we're back at the last problem. Square root both sides. Not forgetting to take the plus and minus of that. Of x plus 5 equals plus and minus root 13. And x equals negative 5 plus or minus root 13. A great way to avoid the quadratic formula. I'm not a fan of the quadratic formula because it takes a lot of making sure you're adding, subtracting right. There's a whole bunch to do in there, whereas this is pretty straightforward. So this leads us into solving by completing the square. Now in this case, we're looking at a quadratic that does not factor. Okay, even though there's a 9 there and there's an 8 here, it's got to be positive, so it's not going to factor. So there's a process to complete the square. Basically, the first thing you do is you make sure the a coefficient, that's this guy right here, a coefficient, is equal to 1, and it is, so that's checked off the list. Secondly, you isolate the variable terms. So in order to do that, I get the x and the 8x on one side of the equation and a negative 9 on the other side of the equation. Check. We're going to take half the b term and square it. So if I take half the b term, which is 8, and square it, that equals 16. Check. Going to add that term that we just got, the 16, to both sides of the equation. X squared plus 8x plus 16 equals negative 9 plus 16. Now you're going to notice, hey, look at this guy. What I just did was I completed this process in order to get a perfect square, hence completing the square. So this is x plus 4 quantity squared equals 7. Take the square root of both sides. Don't forget the plus and minus. Get x plus 4 is equal plus and minus square root of 7. And x equals negative 4 plus or minus the square root of 7, solved by completing the square. Now, how do I know that completing the square is a good idea? All right. Typically, once I've gotten through step 1 and I've got a coefficient of 1 right here, I look at this guy. And if this term here, the b term, is even, that's a great candidate for me to do completing the square. If I were just asked to solve a quadratic any way I wanted to, and it didn't factor, I got two choices: completing the square or the quadratic formula. And even middle term, 9 out of 10 times, I'm going with completing the square. Again, personal preference. So here's another one where we're told to use completing the square. And if you're in an assessment situation and I tell you to use completing the square and you use the quadratic formula and get the right answer, you're going to get 1 point for the right answer and you're going to miss 4 points because you didn't do it the way I asked. So I got to get a coefficient of 1 here, which means dividing everything by a negative 2. This is going to be a little problematic in the sense that here's my 4x, and now I've got, whoops, let's get rid of that guy. And now what I'm going to have is I'm going to have a fraction, which will freak some people out, but hey, it's just a fraction. Deal with it. So now I'm going to isolate those terms with variables from the constant term, like so. There's that fraction everybody's worried about. I'm going to take half that term and square it. That's going to be a 4, so that's x squared plus 4x plus, there, I'm being lazy, sorry, shouldn't do that. We'll take half of 4 and square it, which is 4. So I have x squared plus 4x plus 4 is equal to, and that's what I added, 3 over 2 plus 8 over 2, which is essentially 4. 8 over 2, sorry. So then I factor, get x plus 2 quantity squared. There's my perfect square. Get 11 over 2 here. Again, I'm going to square root both sides, not forgetting my plus and minus, and I get x plus 2 equals plus and minus the square root of 11 over 2, which isn't going to fly. We're going to have to rationalize by root 2 over root 2. So I end up here with x equals negative 2 plus or minus root 22 over 2, which I suppose I will take. All right. Otherwise, you can simplify that by getting an LCD, multiplying this guy by 2 over 2, and that's negative 4 plus or minus root 22 over 2 in one fraction. If we ever do take SATs, then this may be the answer given as opposed to this. So you got to realize what you're looking at. So here's another completing the square problem, and like in the last problem, we said it was a little bit problematic because we had a fraction. There are no fractions here, and we have this coefficient of 1, which is great, but if I had my choice, I don't know that I would do this using completing the square, because this middle term, the b term, is a fraction. I'm asking you to do it that way this time, so we have to, but if I was given a choice, this may not be my choice, and I'll show you why. I've got my x squared plus 3x is equal to 3. Take half the middle term and square it, giving me 9/4. Well, I have to complete that process, and now I have 3x plus 9/4 is equal to, we're going to take this and make that 12 over 4, which is 3 plus 9 over 4. Now, people get freaked out. They don't know how to factor this, but you do, because this is a perfect square. All right, x is squared and 9/4 is squared. What is the square root of 9/4? There it is, right above 3/2. And you're saying, well, that's not going to work. Well, sure it's going to work, because if I multiply x times 3/2, that's 3/2, and x times 3/2, that's 3/2. 3/2 and 3/2 is 3. Done. And then when I multiply the 3/2 together, I get 9/4. So we're good to go. Got 21 over 4 here. And in this case, what we're going to do next is we're going to take and basically square root both sides of the equation, as we've done all along, and end up with x plus 3 over 2 is equal to plus and minus the square root of 21 over, and you'll notice square root of 4 is 2. So now when I take and add this to the other side, I have negative 3 plus or minus square root of 21 over 2. Now, each of these answers has been real, first of all, a real number, and in this case and the previous case, because it had a square root in it, it is irrational. Now, you can have answers that are complex. All right? In other words, there may be a case in time where I get an answer like 5 plus or minus 2i root 3 over 7, something like that. And if I got an answer like that, and they just asked you to solve by completing the square, that's an actual answer now. Now that we have complex numbers in our lives, that's an answer. Now, if it said, find all real solutions, then this is not a real solution, and you could then say, hey, this has no real solutions. All right. Now, we're at a point where we're going to use a quadratic formula. Why would I use a quadratic formula for this? Because if I was to complete the square, I'd have to divide by 3 and not only do I have not an even number here, it's a fraction, all right? And then I'd have a fraction here as well. So total pain. So what I'm going to do is I'm going to use a quadratic formula, unless of course this actually factored. I'd factor first. This doesn't, I don't believe. It could. But we're going to use a quadratic formula. In order to find x, given that it's in this form, a quadratic set equal to 0, you take the opposite of the b term. Here's my b. Plus or minus b squared, and minus 4, here's my a term, and here's my c term. So now this is just a case of plug and chug. I got negative 5 plus or minus the square root of 5 squared minus 4 times a, which is 3, times c, which is negative 4. And the reason why I hate quadratic formula is because so many times, even myself and I know students, they'll forget this negative 4 and they'll just throw 4 down there and get the whole thing wrong. And if you think about it, okay, you got to know how to square 5 right, which most people do. Then you got to multiply the 3 numbers together with this negative, which screws people up as well, all right? And then you've got to be able to simplify that square root, all right? And some people have problems with that. So there's a lot of work involved in this, believe it or not. So I have negative 5 plus or minus square root of 25, and that's 12 times 4, which is 48, and that's positive, over 6. A little bit more work. Negative 5 plus or minus 60, 73, which I believe is prime, over 6, and we're done. So that wouldn't have factored. You've been doing that a long time. I don't see a need to do any more of those. Now, in addition to looking at the quadratic, there's something in the quadratic, this term that's under the root, b squared minus 4ac, that is called the discriminant. And the discriminant is basically an expression that describes for us what type of roots, another word for roots are solutions, of a quadratic that we're going to have. Now, quadratics, we know that anything with an x squared is going to make some form of a parabola. Could be like this, could be like this, I don't know. All right? But if you calculate the discriminant and you get a discriminant that's less than 0, then what that tells you is you're going to have a parabola that never touches the axis. Now, it doesn't necessarily mean it goes up this way. It could go down this way. All right? But it will not touch the axis. And when it touches the axis, you get an x-intercept, or what we call a root or a solution. So when the discriminant is less than 0, there's going to be no solutions. When the discriminant is equal to 0, that means that parabola only touches in one place. Again, it doesn't have to be like that. It could be something like this. All right? But it only touches in one place, so that means you'll have only one root. And if it is like this, they call this a double root. All right, and it will only have one intercept. Finally, if the discriminant is greater than 0, then you'll have a parabola that crosses that x-axis twice, either like this or it could go something like this. All right, and in that case, you're going to have 2 x-intercepts or 2 solutions, 2 roots, etc. It's not super helpful, but it gives you an idea what it's going to look like. So in this case, I'd have to find a discriminant and state the number of solutions it has. So right off the bat, I know this is a quadratic because it's an x squared. I know it's some kind of a parabola. Even though we haven't talked about parabola, because this term is positive, you know it goes up. We'll refresh our brains a little bit there. And now I'm going to look at the discriminant, which is basically b squared minus 4ac. All right, and see what that comes to. I have 10 squared minus 4 times 3 times that negative 12. Whoops, 12. All right, and you'll notice that this term is positive, and this whole term right here is positive, so it's going to be greater than 0. I don't even care what its answer is going to be. All I know is the discriminant is greater than 0, therefore 2 solutions. for x-intercepts. All right, I'm pretty much done, and we'll see you next time.